Hello everyone, and welcome to a new episode of Inference, where we talk about programming languages and other fun stuff. Today I'm incredibly happy to have here a great software engineer, a programming language author, and a very committed person to the community and functional programmer, Leandro Ostera. Welcome, Leandro. How are you?
Hey, Michelle. Thank you so much for having me here. Really happy to be able to share a little bit of knowledge about FP. And I gotta say, language author, I think it's a little bit of a stretch right now, but give us some time.
Yeah,
Yes.
I bet you will be a great language author. We will talk
Thanks.
about that later. And yeah, but we should start with the who are you and how you got there, meaning how you started writing FP code, and yeah, word to you.
Cool. Okay, where to start? I've been coding since I can remember. I think I was around 8 the first time I started writing some sort of software with things like Game Maker and whatnot. But at some point, I found myself trying to make some money, and I found that PHP and Ruby on Rails were like a good thing to make money with, right? And so I did a couple of years of that. I must have been 14 when I started. And one of the things I loved the most about working with Ruby in comparison with like PHP was that, in Ruby, you have this way of building some sort of like chain pipelines of data transformation. Like you get some data out of a database and it's like, an array of things, and you turn some of those things into hash maps, and then you do like dot map, and then you pass a block, and then you reverse it, or apply a filtering, right, or a sorting, and then you say like dot unique, and this data is being transformed, right, by all of these different sort of applications of different blocks, and I really enjoy that. But working on web development, at some point you gotta take a step back and say, I am only moving JSON in and out of a database, right? I am grabbing a form and turning it into something that goes into a database and then comes out and then is shown to a user. And I found that, it started to feel a little stagnant, like I'm not doing interesting things, which is not to say that that's not interesting, just that I stopped finding it interesting at some point. My problems were just not big enough, right? But I started wondering who is it that has bigger problems, and I found the companies like WhatsApp or Facebook or Google or Microsoft, and in particular WhatsApp at that point in time was like booming with this headlines like 30 engineers have built a service that supports 1 billion users, and I was like, well, that's kind of cool. What are they building that in? That seems like a big problem, right? And they were building it in Erlang. So I thought that maybe learning Erlang would actually teach me the tools that I needed to fix or work on these big problems, right? And that will mean that companies that have big problems will want to work with me. So it turned out that Erlang was a functional programming language. It's not what I thought, right? I wasn't looking for that. But when I started writing it, I realized, syntax aside, right, that you're doing the same thing that I was doing in Ruby. You grab some collections of data, right? And then you start transforming it by applying functions to it. It looks very different than you would do it in Ruby because there's no pipeline operator and you can't just like chain functions and whatnot. But conceptually, it's there. And I was kind of hooked.
Okay, that's awesome. Yeah, I can talk for me when I say that I've started working with PHP, and then when I've seen Ruby for the first time, I fell in love immediately. And when I started writing React code, and people were telling me that I should write FP code in JavaScript for writing proper user interfaces in React, that reminded me a lot of Ruby and my love for the way that Ruby can be expressive when handling data and stuff like that. So I had a similar path, and then moved to Elixir. So that's how I entered
that's
the
like a great
beat.
jump, right, from Ruby to Elixir. Yeah.
Yeah, but it was for the syntax at that moment because I remember the Ruby syntax, and I said, okay, I have some difficulties in knowing functional programming in Elixir, but thanks to the syntax, I fell in love with Elixir and the Beam. So, okay, and we talked about your passion to OCaml, and how did you start writing OCaml after, Erlang?
That's a good question. So at some point, I kept learning Erlang, right? And I, at some point, just pushed all of my money into that. And I said, I'm going to go to the Erlang user conference. I'm going to actually, meet the community. And I accidentally got a job at Klarna. And I was super happy because I moved to Sweden, and I'm Swedish now after like 6 years of doing that. But I got to work on rather large problems in a language that is functional, so I was super happy with that, which meant I could exercise my FP muscles, right? And see the good sides of it. Right? There was a lot of property-based testing, for example, going on there. And they're one of the largest Erlang code bases as well, so they work with a lot of Erlang expertise, especially in their core teams. But it showed me that FP can have some drawbacks, right? Like there's some trade-offs to how Erlang works. And one of those is that it's quite dynamic, which means a lot of things can't be known until you run the code. And I just kept looking around. I had one coworker, Daniel McCain, and he kept telling me, bro, you gotta learn Haskell. And I was like, nah, that's too much hassle, and so on. But eventually I decided to give a shot to Idris, and I felt this is just a fantastic language. It's just kind of sad that it's not used so much in production. I mean, it was a research language after all.
Yeah.
And I tried to dial it down back to something that felt to me that I could get my hands on and get shit done while still being able to have all of this type safety, still being able to write a large amount of code and refactor something. Because what would happen is that if you didn't have the right number of tests, right, or the right kind of tests written for an Erlang code base, if you do a change, there's a good chance that you're going to break parts of the system and you won't know until you release it. And that happens with Elixir as well. Even though Elixir has some more, static sugar on top, like structs, for example, you still have those problems. But in OCaml, I felt like most of those things, even though you still need to write test and logic can still be wrong, a lot of those bugs just disappeared at compile time. You were told, hey, this is what you broke. This is the cost of applying your change. So I just got into OCaml and started doing that. I recently had a big sort of role in my adoption of OCaml.
Okay, and which difference did you see between OCaml and Erlang mainly? I mean, they are two different beasts, of course, but what would you bring to the Beam given, the OCaml syntax, compilation time, and whatever? What would you like to steal from OCaml and bring it to the Beam?
So let me touch the first point there. You said that they're different beasts, and I agree. Yeah. But I also think they're different in very similar ways, or like they have, a lot in common. It's like saying there's a panther and there's a lion, and they're both like big cats, right?
Okay.
Which means they share a lot of stuff, even though when you look at them, it's like, these are very different animals. And they have different behaviors, and they look different, and so on. But if you squint long and hard enough, you just see that the two of them are actually lambda calculi. You look at them and it's function application over data. One of them allows you to mutate the data and has other sort of sugars on top, like objects, right? But they share a very, very strong core. So, going back and forth between one and the other, it's not that big of a difference, except for the syntax, of course. Okay. Now, when it comes to what are the parts of OCaml that I would like to bring onto Erlang, I would say the first one, non-obvious, is the module system. Erlang has this flat module system, right, where every file is one module, and the module sort of has to have the same name as the file, right? And it has a flat namespace as well, which means if you have a file called, michel.erl, and I have one called leandro.erl, then those modules will be like at the same level, regardless of how we structure a code, or regardless if you're building a library that's separate from mine. If we happen to put the two together, like as dependencies of another project, right, then that project cannot have a module called Michel nor a module called Leandro. Those are things.
Okay.
The module system in OCaml actually, it's almost a language of its own. You can define structures of what you expect a module to be. You can define functions between modules, right? So if you give me a module that has a type T, right, and has a function for equality between two things of that type T, then I can give you back a module that implements a map, like a hash table, right? For that specific type. So you can do code generation in a type-safe way by applying modules, right? Like if they were functions. It's kind of like a templating mechanism. I think templating is a easier way to grasp it, right? Than trying to think of it as functions over modules. It does have a lot of other things that, for example, you can treat a module as a value, and things do get a little more complex down that line. But in general, I think that the module system in OCaml is something that I would love to have on the Beam.
Okay.
Yes. And of course, the type system, right? But I think already having the module system would mean I could write code so much more in a much versatile way.
Okay.
Yes.
And vice versa. Is there something that you'd like to bring to OCaml from Erlang or Elixir? You can also talk about OTP if you want. If you want OTP on OCaml, I don't know. What would you bring?
Hands down, I would bring the runtime.
Okay.
And the community, especially the Elixir community. It's just that community has built so many quality of life tooling for developers. And I think that we need more of that in the OCaml on the Reason side and in the Rescript side these days as well, right? The runtime, though, it's something that has been in the works for a long time now. I don't know how many years it's been, but it's become like a running meme that multicore will be here next year, and so on.
Yeah.
It seems like it's almost there, right? And I haven't tried it myself, but I've seen publications and I've tried to read some of the papers as well. This retrofitting parallelism into the OCaml runtime paper, and there's really good work there. But of course, that runtime is going to go out and it's going to be brand new and it's going to be well tested, but it doesn't have the 30 plus years of sort of production usage battle testing that the Erlang VM has. And it's going to be a while, not that much, but my guess is it's going to be a while before people just can naively trust it like we do with the Erlang VM, right? If you tell me something is running on the Beam, I'm like, okay, hands down, this is going to be a reliable service. If you've followed OTP, then I have nothing to worry, like 9 nines of availability off the bat. Don't quote me on that, though.
Okay, and you told me about the community, especially the Elixir community, and it is clear to me that Elixir bring, more developers into the Beam and the Erlang ecosystem in general. Don't you think that ReasonML or BackleScript or other abstractions over OCaml could bring potentially more community to the OCaml programming language?
They have. I feel like they have. If you look, for example, at the Erlanger and the Elixir Slacks, there's about an order of magnitude jump in the community size. The Erlang has 4,000 people registered. I don't know how many of them are online. If you go to the Elixir one, I think last time I checked it was like 29 or 30,000. That's a jump, a big jump.
Yeah.
I don't know that Reason or BuckleScript or Rescript have had that kind of impact on OCaml just yet. But I could definitely tell you that if you look at the two Discords, because the OCaml and Reason community are on Discord, they're not doing Slack stuff, mostly, right? If you look at the numbers of people there is a gap, a jump as well. Sometimes I go to the OCaml Discord, right? And most of the people there are names that I already know because I've seen over and over and over. And it's people that are working on compiler, right? They're working on some of the most advanced sort of kind of tools that you can build for development, like, type-safe macro systems, that sort of thing. And when I go into the Reason Discord, then I see a lot of people that are getting onboarded into the platform. It's like, hey, how does a variant work, right? And it's good. We need more people to join, right? So that we can build better documentation and better tools and so on. But you can clearly see a difference between the folks that are getting started, like onboarded into the platform on the Reason Discord versus most of the people that have been using OCaml for, let's say, a decade at least, right? In the OCaml Discord. I don't know if that answers your question, though. I think
Yeah, absolutely.
Just sidetracked a little.
No problem. Going back, differences between Erlang and OCaml. I've seen many people calling OCaml an Haskell without the magic, whatever it means. But before we started the recording, actually, we were talking about the way we implement programs in both languages, where we can say that OCaml has a more defensive way of building software, meaning that we don't have, like in Erlang, an actor supervising a process, and if that process crashes, it take care of that process. And how do you see the differences between the way we write softwares in OCaml and Erlang? What are the main differences that come in mind when talking about
Right.
that?
There's an obvious one, and is that in Erlang you can write stuff that will compile just fine, and then it will crash immediately. That doesn't mean that you can't do it in OCaml, but normally you don't aim to do that in OCaml. You try to make sure that whatever compiles will run, right? I don't think that OCaml claims that Haskell guarantee that if it compiles, it runs, right?
Okay.
It's a lot more pragmatic than that, because it's not pure, for example, or it's not lazy. So as an impure, strict language, you can shoot yourself right in the foot, right? Very, very easily. But at the end of the day, both communities sort of arrive at, they're trying to go to the same place. They're trying to build reliable software, something that you can bank on. And I think both of them have proven over time that you can do it in both different ways. We have massively scalable systems written in Erlang that have nines and nines and nines of availability, right? They're essentially never down. And on the other side, we have companies like Jane Street. And I know that that's like the name that comes up the most when we talk about OCaml, but they're doing quantitative trading with OCaml. Like, of course, they write a very specific kind of OCaml that leverages the runtime and understands runtime. But they're moving a lot of money through that. And I would venture that if you're willing to move money automatically with a machine, you're pretty confident in that machine, right? So on the one side, the OCaml community has developed, this type system, this module language, the ability to scale a code base, both in terms of compilation time and refactorability or maintenance, ability to be able to maintain it quickly and effectively, by trying to reduce the number of bugs, right, that will ever appear, right, when you run the program. So you try to catch as most things as you can when you compile it. Okay. And on the Erlang side, people have gone, well, software fails, stuff breaks. So let's just take a step back and say, all right, my program is going to fail at some point. I need to figure out how to work around that. Not work around it as I'm going to skip it, literally work around it and say there's a failure, and a failure is actually like reified, is a value. And you could think of an exception, right, as a similar thing, right, like a refined failure. But normally languages don't allow you to recover very nicely from exceptions, especially ones that you don't know about. Like something crashed somewhere. Okay, my entire OCaml program goes down, and that would happen for most languages. But in Erlang, with the supervision trees, you can say, here's my program. If it crashes, however it is that it crashes, right, let this older program know that so it can restart it and so on, which is, the whole OTP philosophy.
Yeah, absolutely. Okay, and talking more about the paradigm, Erlang was invented, for being a very reliable programming language and runtime. And when the Erlang authors were, studying Erlang at the beginning, they came up with the idea of a functional language because that was the best way in that moment for solving many issues. The main idea wasn't to build a functional language, but they ended up building a functional language because of the goals that they wanted to achieve. On the other side, we have OCaml, which comes from the Camel programming language, plus the O, which stands for objective. And here is my question. In your experience, is there anyone writing object-oriented code in OCaml? Because I personally never seen that, but I'm 100% sure that I'm wrong.
Yeah, so for the longest time, I was very against OOP, especially after I moved from Ruby and was like, oh no, Ruby sucks. OOP sucks. I will never touch that again. These days, I'm like, yeah, an object is just a closure, right? It just has some state in there. You can use it. I think the the main benefit of the objective system in OCaml is that it gives you this structural typing, right, over objects, which is essentially the ability to say, I need an object that has this property. I don't care what object you pass in as long as it has that property, right? Whereas most of the time you have nominal typing through records, right? So I need a record, but it can be any record that has this thing. It has to be this exact record by name, right? That's the one. And there's a lot of tools that need to be built with structural typing, or that are easier to build with structural typing. Off the top of my head, I know two. Menhir, the sort of parser generator library or toolset, SDK, uses the object system quite a bit under the hood. And the second one is the AST helpers libraries in the compiler. I think Drup was the one that wrote that. And last time I was playing around with that, trying to do a mapping over the AST, it was like, okay, you have to define your object, right? And just instantiate your object with this particular set of functions. And then you have these visitors, right? Built for you for free. And it was pretty convenient. Now, I think that most of us associate OOP with like mutable state everywhere, or like Java style or C++ style object orientation. But it doesn't have to be that way entirely, right?
Okay.
It doesn't have to be like hierarchies of classes and like singleton factory pattern, generator builder or something like that. It doesn't have to be that.
Okay, great. And one of the goals of my podcast is to spread awareness of how less mainstream languages, such as Erlang or OCaml, have influenced the way we write software today. So here's my question, more about OCaml.
Yes.
How do you think that OCaml has influenced the way we write software today, knowing that, for example, Rust, which is one of the most loved programming languages out there, has been built in OCaml, and it's clear the influence that OCaml had in building Rust. So that said, how do you think that OCaml has influenced the software we write today and the way we write it?
I don't know if OCaml has been the main influence, but certainly standard ML, which is like a parent of OCaml, right?
Okay, yep.
Like the grandfather of OCaml or grandmother of OCaml. I think that many languages these days are trying to help you model your data in a way that it can be mechanically checked, right? For example, having records or variants. Records are not a new thing, and variants are not a new thing either. But many languages have had structs and enums in the past as just a way of saying, here's an enumeration, and this will be numbers, right? That you can use these names for. But with variants, right, you all of a sudden get a way of talking about disjoint pieces of data, which are not the same as an enum. You could try to fake enums, right? Fake variants with enums or vice versa. But they have pushed languages towards helping the programmer say, this is the domain I am working with, right? In a way that a machine can sort of mechanically check through things. Now, I personally think that OCaml has scrambled my ideas a little bit. And now every time I grab a language, doesn't matter if it's typed or untyped, I have a way of thinking of how to split my code and how to write it, right? Even when I'm doing JavaScript, I just create one .js file, and this will be my thing, like a user, right? And inside there will be functions for creating a user and manipulating it. And I really try not to let that type escape, even though there is no type, right? It's just an object. So in some ways, I think it's taught me how to think in a way where I encapsulate my data and I provide nice interfaces to operate over it without leaking details. Sort of patterns that scale nicely when you have a type system, that when you don't have a type system, still actually help you write code like more efficiently, I believe, or at least for me, right?
Okay, yeah, and talking more about OCaml, we've talked about before the recording how you used to write code, let's say Java code, for example, in many big companies such as Spotify and other companies. And which is the biggest difference that you've noticed when switching from object-oriented language such as Java to OCaml? I mean, it's clear to me that there are many differences, but which was the greatest difference that you've noticed between those two languages?
So I would say that the biggest difference between languages was not the language, but the tooling.
Okay.
You can still
Sure.
write Java in such a way that it's a little functional. Classes are just records, right? You put a bunch of data there,
Yeah.
and then you treat the data immutably. So the methods actually return new instances of the class and so on. I'm not advocating for that. I don't even know if the JVM will be work nicely with that kind of patterns.
Now, we can say that we can use the functional interface in Java for, writing more functional code.
Yeah,
That's it.
let's say that.
Okay.
But the thing I found the biggest difference has been that the tooling around it lets you write Java in ways that I can't write OCaml today, right? It's kind of hard still with great projects like Merlin or the OCaml LSP. It's still kind of hard to say, well, bootstrap a module with a type, right? And then sort of refactor that type by just banging my hands on a keyboard on one keystroke. IntelliJ idea, right, for Java, I don't know what the actual command is, but I think it's like Command V on a Mac, right? It opens this menu to fix some errors or do some refactorings. And I remember having colleagues just smashing that key, and I was smashing that key as well.
Okay.
And stuff got done. You know what I mean? It was like all of the refactors were rather easy. It was straightforward to run tests from there, to run the tests that you wanted to run, and so on. And I think that makes such a huge quality of life difference that the language begins to matter less. Which is not to say that you should stop writing OCaml and go write Java. No, please don't do that.
Sure.
But let's work on getting the tooling in OCaml to that point where I can just smash Command V, right? And then get paid to do that.
Okay, so basically, I think that the reason why OCaml doesn't have that kind of tooling yet, it's mainly because of the popularity of the language, and companies are not building, that kind of tooling for not so popular programming languages. And that said, why do you think that OCaml took a bit more when compared to other languages to become such popular? Those days. I mean, it's clear that those days OCaml is becoming more popular thanks to Facebook, Mozilla, and other big players in the industry.
Yeah, I think that popularity is bound to sort of a group of people, right? How well something is known within a set of people. And if you grab the entire population of programmers, I think OCaml is almost like unknown. But if you grab a specific part of the population, then you can say, oh, OCaml is a very well-known thing. If you grab most people in academia know about OCaml at the very least, right? Outside of there in the industry, I would say most people don't know about OCaml or have heard OCaml written down or spoken once or twice. I do feel there's a huge survivorship bias in the community, which sort of has impeded, maybe not impeded, but slowed down the creation of tools that would make some tasks easier, right?
Okay.
I think companies like Jane Street have invested a lot of money into making that better with tools like Dune, for example. It's an epic build system. I love it. It has its drawbacks, right? But it's really, really good. But most of the time, when you look at the community is very perseverant. It has a high tolerance for pain, I would say.
Okay.
Like these days, if you want to write a backend or a front end to the compiler, you have to start looking into stuff that's completely undocumented, right? Muddle through type definitions in the source of the compiler and ask people that wrote that stuff how to do things, right? And that's a pretty high bar, right, for getting started on hacking with the compiler. Maybe that's intended. I don't think so. I just think that, nobody actually put time into making that easier. So it's gotten hard. And the people that wanted to do it did it. And after that, they were like, well, once you get around the compiler types, then it's kind of easy. But that's the survivorship bias, right? Okay. Because you've gone through it and you think, now that if you now think that it's easier because you've gone through it, then you're like, well, it can't be that hard. So other people will go through as well, instead of let's actually figure out how to make this more approachable for everybody else, which is not necessarily the goal, right?
Okay, great. And talking again about the industry, I've seen many companies nowadays switching to more functional approaches for building software. And there is one company in particular which is advocating a lot for OCaml, which is Facebook, of course. I'd like to know your personal opinion in why there are companies such as Facebook advocating for OCaml rather than, Haskell or other functional programming languages.
That's a very good question. I don't know if I have a eloquent answer for you for right now. I also don't know that Facebook is pushing for OCaml, right?
Oh, I mean, maybe it's just my idea, but I clearly see that they created ReasonML and they created it for writing React at the beginning. I mean, React was built in ReasonML originally. Then they pushed ReasonML outside using BackScript and whatever. They are using it for creating static type checkers for
Yes.
Java, C++, and other languages.
They're
And
definitely using it a lot. Yes, that's correct.
yeah,
Yes.
it's surprising to me. I mean, I thought such a company like Facebook that hired the people from the Haskell community would have been writing more Haskell, actually. But I see many people in Facebook coding a lot in OCaml, and it's surprising to me. Why do you think that companies are actually choosing OCaml for writing software, and why people should start writing OCaml? Which are the advantages of that language?
Yeah, I think I understand what you're going to. I would say that writing OCaml is a good idea if you need to write a lot of code, like large amounts of it,
Okay.
for some reasons. And I think this will be like a tree. Like if you need to write a lot of code and this thing and that thing, then these are some of the reasons, right? So let's
Okay.
try to grab the first one and help me go back to that tree thing because I'm gonna forget. But if you need to write a lot of code, OCaml has some really interesting things for you. For example, it's quite concise, so you don't have to write a lot of stuff or semicolons or braces, and there's a lot of boilerplate or I think ceremony would be the right kind of word for this. There's not a lot of ceremony to get stuff done, right?
Okay.
However, sometimes, every now and then, you will need to push the language a little further, right? And you will need that ceremony. If you do need that ceremony, then the module language, right, comes in to help you sort of template over code. So you can write more code with less code. Like that's sort of what templating does.
Okay.
So those will be two things. So you can write a lot of code. Now, if you write more code, then of course you have more code to test and more code to compile, right? And more code to deliver. OCaml by default will type check the entire damn thing, right? So if you make a change in one of your 10,000 files, then it will make sure, right, that everything still makes sense. Everything still sort of is sound together. Which means the compiler has been optimized to be fast and work in an incremental fashion, right? This means that if you have 10,000 files, then if you want to recompile one thing, then you just need to see that the interfaces of the things you depend on have not changed, right? And if they haven't, then you can use that information to type check only the module that you are modifying.
Okay.
The rest of the tree you can leave. Now, the compiler is pretty dumb in that sense, so tools like Dune actually help it figure out what files to keep track of, right? Because if you had to say, here's my 10,000 files, and you call the compiler once with all those things, then it will take a long time, right? But the tooling around it is built so that you get this incremental recompilation, incremental type check-in, just out of the box, which is great. When it comes to tests, right? I don't know that we right now have anything to do incremental testing, but the type system is expressive enough that there's many things, right, that you can embed into it, right? So if you do a good job by using the types in nice ways, following some patterns that the community already has found work and scale well, then you will need less tests for some things. That doesn't mean that you don't need to write tests. Please write your tests, right?
Okay.
Writing good
Sure.
software is hard, and we need all the help we can get. So tests, good. Types, good as well. Types and tests, better.
Okay.
But that means that you can run you can write some less of them. Like you don't have to check if something is a string or a bool. You can just say type system, please enforce a string here, and then you're done. Another thing, as your code base scales and you need to run your tests, you will need your tests to run fast, right? If you don't have incremental testing, then you need to figure out how to make your test run in the least amount of time possible, right? Because you have to run all of them over and over and over.
Yeah.
OCaml can compile both to a bytecode interpreter that actually can be compiled to JavaScript, or can be compiled to native executables, right? Which means if you compile your test to a native executable that OCaml claims is 50% the speed of C, then you can run a lot of tests real fast. I think Jordan Walkie from React and ReasonML fame,
Yeah.
he had a project where he was showing that, with Jest, you could run like 100 tests in 30 seconds, right? Something like that. And then with his alternative for ReasonML native, you could run 1,000 tests in 2 seconds.
Wow.
It was like
Okay.
crazy. I think those are some compelling points for scaling code base, right?
Okay, and that's it. I think OCaml can be a really appealing programming language. And for people, of course, that doesn't know anything about FP and wants to get into FP more, how would you suggest for people wanting to learn OCaml to get started?
Well, that's a great thing. Like educating people to get into OCaml is actually rather cheap, especially if they come from imperative backgrounds, because you can absolutely write imperative programs in OCaml. 100%. You don't have to be like, well, I have to sit down for months to try to wrap my head around what's a monad, right? To be able to write any OCaml, okay. You just sit down and say, here's my variable, it's mutable. Push stuff to that, right? And your program will run. Over time, you can start adopting more functional patterns that will actually make your programs run better. The runtime is optimized for functional patterns, right? But you could be writing imperative OCaml today and slowly start adopting functional patterns, right? And because you can encapsulate things quite neatly, then bring someone new into the team that has some C experience or JavaScript experience, right? And hasn't done like more hardcore typed FP. You can still have them work the way that they understand how to work today, deliver the value that you need to deliver in a business development team, right? And slowly over time, help them understand how to write FP style OCaml.
Okay, great. Now, going into the conclusion for today, what are your thoughts about the future of OCaml? I've already talked about Erlang in the past episode with Brujo. Today, I'd like to ask you the same question with OCaml. What are your thoughts about OCaml, Rescript, or ReasonML? And what's the future of that ecosystem?
That's a very good question. I think, like to me, one future for OCaml will be to be, a universal type checker sort of thing.
Oh, okay.
Where I'm not that interested in the actual, two executable or two bytecode compilation of the OCaml compiler right now. I'm more interested in the type checker itself. And I think it would be really nice to be able to use that more modularly, right? Embed it into other languages, to be able to use that as like the first layer of abstraction across a bunch of runtimes, right? Which is kind of what I'm trying to do with Caramel, right? You have OCaml, and OCaml is a great language. It's very expressive. It has a sound type system. It's actually very pragmatic. And once you get around it, because it's not that big of a type system, you get very, very productive in it, right? So if you do that and swap the different backends, right? You could be running natively. You could have like an IoT style compiler. You could have the unicurl compiler backend, right? So you can run a single language across pretty much every target that you want. And that will make the language rather powerful, I believe, right?
Yeah, absolutely.
That is the case today, but it's not as straightforward to build a backend.
Okay, so you anticipated actually a topic that we will be covering in the next episode, which is Caramel. Would you like to spend a couple of words on what Caramel is and why people should listen to us in the new episode?
Right. Well, I think that you should listen. I'm speaking to you, listener, now. I think you should listen to the next episode where we're going to introduce and present Caramel. Caramel is a backend for the OCaml compiler. It started as a backend for the OCaml compiler that will let you run some OCaml code on the Erlang VM. right? So all of this type safety we've spoken of, right? All of this modularity and sort of scalability at the code level is now mapped or matched, right? Enabled on top of the massive concurrency and massive scalability of the Erlang runtime. It started as a backend to the compiler, and we've taken steps toward turning it into an actual language. It will be OCaml compatible, but it will let you build this, scalable applications, maintainable applications in a type safe way. So you should totally join us for the next episode on Caramel.
Thank you. That was awesome. So thank you again, Leandro, for being here today. It has been a real pleasure. And looking forward for the next episode. I can't really wait. I will get my hand dirty with Caramel before talking with you again, so I can ask you very specific questions, I hope. See you next time.
That's
Thank
awesome.
You again.
Yeah, we just did a very tiny release, and I'm pushing some changes to the Mix Caramel plugin, so it'll be even easier for you to try these things out. And again, thank you so much for having me. This has been a lot of fun, and I'll be seeing you soon.